Welcome back to Azure Makes, where today I'm going to show you my replica of the Sinner's Sacrifice from Deadlock. Here we go. Whoa, wait a second. I got a little too excited there. You probably want to see how I built it, right? I have the state machine implemented.
I made a recreation in FL Studio.
Standing is not my favorite.
This is suboptimal.
Ooh, damn, they look sick. This is by far my favorite electronics project I've ever done, so I hope you enjoyed this video.
Statistically speaking, you probably have no idea what Deadlock is, given that it's still in early development and currently requires an invite to even play, though it's pretty easy to get one. So let me introduce you to the game. Deadlock is a 6v6 third-person shooter MOBA set in an alternate history New York City with a steampunk-adjacent visual style. Development on Deadlock is believed to have started in 2018, and its existence was first leaked in May 2024. Excitement within the gaming community immediately started building around the idea of a new Valve title, given their pedigree as a game developer, and specifically as the developers of huge multiplayer titles like Dota and Counter-Strike. Speaking of which, I also built an extremely realistic replica of the C4 from Counter-Strike, and have a video covering that journey on my channel, though there's a non-zero chance you'll be added to a list if you watch it. Given the fact that the game is still under heavy development, you might question my decision to invest a ton of time, money, and energy into building a replica of a prop that might not even make it to the full release of the game, and if it does, most likely won't look the same. To you, I would say, you're absolutely right, and I'm going to be pretty sad if that happens, but we're doing it anyway. Let's talk about what exactly I'm going to be building a replica of. Throughout a match, a type of object called the Sinner's Sacrifice spawns around the map that players can interact with to gain souls, which is the game's currency that's used to buy items that make your character stronger. The Sinner's Sacrifice is one of the most iconic things currently in the game, and works really well to add to the game's overall charm. There isn't much in terms of lore that I could find, but the model features some ominous signs that imply the machine runs on blood sacrifices. There's a pretty cool looking lever mechanism attached to the side with some blood trickling down it, and 3 slot machine style spinners on the front. The machine's full of glowing soul orbs stored behind some glass, and there are 9 eye-catching light bulbs at the top. The machine idly plays some cheerful music to let nearby players know it's there. To harvest souls, a player has to punch the machine until all the lights at the top go out. At that point, the lights will start relighting from left to right, and to get a jackpot, the player has to punch the machine exactly when all the lights are relit. If you get the jackpot timing right, you get some extra stat buffs as a reward. When punched, the machine plays a sort of smashing sound effect, and when a player hits the jackpot, it plays a different short musical clip. So in terms of a replica, we have a bunch of things that need to light up, some things that need to move, a bunch of audio that needs to be played, and some user input to monitor for. We got a project on our hands. To start off, I was able to go into the game's files and extract the in-game Sinner's Sacrifice model and bring it into Fusion so I could work with it. The first thing to figure out was what brain I should put in this thing. I definitely need the ability to write code to perform the logic of the machine, so that means I need a microcontroller. I did some research, and I'm going to go with Adafruit's Feather ecosystem of products because, as I'll explain later, they have a specific add-on board that's perfect for the audio part of this project. I went with the Feather RP2040 because the RP2040 is pretty popular and well supported. So, on to how I'm going to play audio from this thing. I want it to react with sound effects when you punch it. Well, hopefully no one actually punches it, but I want it to react to light bumps. Luckily, Adafruit has that perfect add-on board I mentioned before, which is the Music Maker Featherwing, which actually has an amp on board and can directly drive small speakers by streaming audio files off an SD card. So that's pretty much perfect because I won't have to actually deal with the most complex part of this project, which would be managing the playback of the audio without an operating system to handle all the multitasking that would be required to do that. I also decided to grab 2 3-inch speakers from Adafruit as well. One quick note, unlike the C4 video, I'm limiting this project to only off-the-shelf electronics so that it's easier for people to recreate themselves. I love the process of designing and building circuit boards, but I think it makes it hard for others to reproduce the project and enjoy it themselves. Also, starting with this video, I'm going to be uploading all the files from my projects on Patreon with comprehensive documentation and instructions on how to reproduce them yourself. If this interests you, the link's in the description. Sorry, let's get back on track. The next thing to figure out is the best way to do the lights at the top of the machine. My plan is to use addressable LEDs for this because of the minimal wiring compared to individually wired LEDs, and I won't have to worry about supplying a bunch of power through my microcontroller. I have a video coming soon in which I explain why addressable LEDs are so powerful, so I won't talk about it now, but just know that they're super cool and you should be excited to learn about them. I also plan to use addressable LEDs to light the soul orbs inside the machine, but I'm kind of just waiting to do that whole part of the project until I have the other big pieces integrated and figured out. So the next thing is how I'm going to actually detect punches. The most obvious choice is to include an accelerometer, but I actually found that these little vibration sensors that Adafruit sells seem way simpler, so I'm gonna give that a try. Basically, there's a really soft spring inside and it makes contact when it moves, so I'll just supply some voltage to one side and monitor the other side to detect a punch. Aside from the audio, the other complex part of this project is gonna be spinningless spinners on the front. I could go with a simple DC motor, but I think I'm gonna want some pretty fine control over the speed and acceleration, so I'm gonna go with a stepper motor instead. Adafruit sells a TMC 2209 stepper motor driver breakout board. Then my plan is to basically use the stepper to turn a wheel inside the bottom part of the machine that contacts the spinner and spins it. Also, I'm just going to combine the 3 spinners into one because I feel like that's a good trade-off. Then to power the whole thing, I'm going to use a USB-C wall power adapter with Adafruit's USB-C power delivery dummy board and wire the 5 volts around everything that needs it. By the way, Adafruit isn't sponsoring this or anything, I just really like their stuff. They do a bunch of cool work, especially with libraries for Arduino stuff. Also, I figured ordering from one place is nice because if someone wants to do this project themselves, they only have to pay for shipping from one seller. And that should be it for my plans for the electronics. I guess the next step is to add all these parts into Fusion so I can make sure they fit before I order them, and then add the mounting holes, and we're good to go. So I went in and added all the electronics, and it seems like everything's gonna fit pretty well. I also added mounting holes to fit all the parts together using heated inserts and screws. Now it's time to order all the parts and discover whatever horrible miscalculations I've probably made. All right, this is Christmas morning. All right, so here's all of our parts. We've got our wall adapter to USB-C power supply. It's got a switch on there, so that's nice. I don't have to put a switch in the housing anywhere. We've got our USB-C power delivery board. We've got a bunch of stepper motor parts. We got the stepper motor itself, stepper motor breakout, some heat sinks for the driver breakout. We've got our metal rods here for the spinner on the front, the bearings also for the spinner on the front, supports for the spinner as well, vibration sensors here, speakers there. To play the audio, we've got our Feather Wing, which is going to let us play audio from the SD card. And we've got our Feather RP2040, which is going to run all the code that we write. And over here, we've got our addressable LEDs. All right, let's get going. We have music. So we've got our Adafruit Feather down here on the bottom, and we've got our Feather Wing on the top here. This is the SD card that stores the audio files. It worked really well so far. Shiloh's a nice seat. So I think the audio part of the project is good, so I'm gonna move on to the stepper motor. This is our stepper motor driver. It should be almost silent, so that's good. Should be sort of what it looks like once we have the slider on there. So it'll be supported on the sides, and then the bearings will sit on that rod in the middle. And we've got the stepper motor mount to just nicely hold the stepper. Let's go give this thing a try. All right, I did a little bit of soldering and some wiring. I had to add the USB power distribution board into the circuit to start working with the stepper motor just because it draws a lot of current, and I didn't want to draw that just through the microcontroller. So I've wired up the USB power delivery board. You can ignore that one's going to be for the addressable LEDs. But I have a run going to the stepper motor driver, and then one going over to the microcontroller and the audio playing board. So aside from the power, I've connected the microcontroller to the stepper motor breakout board. So now it's time to write some software for the stepper motor to make sure it works correctly, and then we'll see how it goes. Okay, I've got it spinning pretty fast. I don't know if you can see it or not. I don't know if this is actually fast enough. but for now I'm just gonna call it good, and we'll see. Once I have a big wheel on here, you know, the speed might be a little bit faster, but we'll see. Okay, at this point I have the audio playing, I have the power delivery figured out, and the stepper motor functioning, at least. I'm not doing much with the stepper motor and the audio right now. There's no logic to respond to punches or anything. I just have it working at a very base level to know that the electronics are going to work together. So the next step is to start working on the vibration sensor.
I have discovered that little strand is very delicate. This is what I came up with. I have a 500 ohm resistor here, so this is my jerry-rigged solution that should be durable enough.
Alright, so I have added the vibration sensor into the circuit. The pin that I'm using to monitor it has an internal pull down, so it's resting at 0 volts. And then whenever a vibration is detected, it will spike up to 5 volts. I have an interrupt on that pin so that when there is a rising edge going from 0 to 5 volts, it'll run a chunk of code that basically I can use to do whatever it needs to do to respond to a punch. So the only thing left to do is to wire up the addressable LEDs, and then once we do that, I think we're good to start running with the code and really implementing all the logic. So let's do that. A few hours later, I have our string of addressable LEDs. I'm gonna go write some code to see if it works. Alright, so I have the LEDs working and I've implemented the logic to do the behavior of the machine. So when you first power it on, it'll do this animation where the LEDs kind of bounce from the center to the sides and back to the center. And then when you touch the vibration sensor, the LEDs will all light up and then it'll subtract health basically for each punch that you do. And then when there's no LEDs on anymore, it goes into the final state where the LEDs will start relighting from left to right, and then you can try to get a jackpot basically when the LEDs are all lit. So the big thing is I have the state machine implemented to do all the logic of the machine.
Before we move on, let's dive a little deeper into the logic of the sinner sacrifice. I showed you earlier on how the machine works, but writing software to model behaviors like these is often best done by breaking it down into distinct states and then defining the conditions that cause transitions between those states. This method of describing consistent behavior patterns is a model of computation called the finite state machine. Let's look at a state diagram that visualizes the state machine of the sinner sacrifice. To begin, we just have a start state that gives us an entry point into the state machine. When the machine spawns in-game, or in the case of my replica, when the power switch is turned on, we leave the start state and transition to the idle state. Here, the machine's health is set to full, it plays the idle music on loop, and it shows the ping-pong light bulb pattern at the top. It stays in the idle state until a punch is detected, at which point it transitions into a mini state where health gets subtracted from the machine. From here, a decision is made based on whether or not the machine is out of health. If it's not, it transitions into the active state, where it now plays some Foley sounds and displays the machine's current health. It waits for another punch to be detected, then goes back through the health subtraction and decision states and continues this loop until the machine is out of health. Once it is, it enters the critical state, in which the machine plays some more Foley sounds, the relighting light bulb pattern is played, and the jackpot window is opened for a short period at the end of each cycle. When the next punch is detected, it transitions into another decision state, and the outcome depends on if the jackpot window was open or not when the punch was detected. If it was, the jackpot sound effect is played and the lights play a special jackpot pattern. If it wasn't, the machine plays a less exciting sound and the lights turn off. At this point in-game, the machine is destroyed and a timer until it respawns is started. For the replica, the machine will just revert to the idle state and wait to be interacted with again. The software is a decent bit more complex than the diagram showed because I also effectively had to implement a state machine for each different light pattern so that I could carefully manage the timing of everything to match the in-game timings. But I got it done and it matches everything in-game pretty well, so it's time to move on to the audio. If you're anything like me, then you're thinking, there can't be that many sound effects. Like, there's the idle music, the punch impact sounds, the jackpot sound, and that's it. While searching through the game's files and trying to find the sounds I heard in some reference gameplay footage, I was able to find the obvious ones, but I also discovered that there's much more subtle ones and quickly realized there was a lot more packed in there than you think. For starters, the game is in early development, so the files for Deadlock are pretty disorganized and there's tons of files scattered around that aren't even used in the game anymore. Originally, Deadlock was supposed to have a sci-fi style, and there's a ton of leftover assets from that stage of development. On top of that, nothing uses the same name on the back end as it does on the front end. So for example, sinner sacrifices are actually called vaults under the hood, and originally looked like this. So you can imagine the struggle as I'm looking through all the file names for anything that might be useful. Also, it seems that if the developers add a thing that they need a sound effect for, they seem to just randomly grab sounds that are used elsewhere in the game. For example, they actually use the ping sound effect from the active reload item for when the jackpot window opens. Even weirder, the little sound of the light bulb turning back on in the critical state is actually just an obscure sound ripped from Dynamo's kit when you deselect his orb that's just pitched up and down. Seems like it would be a problem if Dynamo gets a rework or active reload gets removed or something, but hey, I'm not a professional game dev. Apparently, a sound effect from Holiday's jump pad is also used somewhere, but I couldn't hear it in any of the reference footage I recorded, so I decided to just not include it. So, needless to say, it took me a while to scrape together a collection of all the sounds that the machine uses, but eventually I felt like I managed to gather them all. I made a recreation in FL Studio of the full sequence of sounds to make sure it all sounded right together and to make sure the volumes were all appropriate. Let's listen to that so you can see how many different sounds there actually are.
What are your thoughts on the replica? I think that's a good sign. So I took all the sounds you just saw and added them to the code. It wasn't as simple as you might think because I can only play one audio file at a time. I can't, play something in the background and then play a punch sound effect on top of it. It's only one file at a time. So I had to do a little bit of work layering the sounds together and then rendering out audio files that correspond to each state machine's state. But I'll show you what it looks like when I do the full sequence with the audio. And with that, the electronics are pretty much done. So it's time to move on to doing some 3D printing, doing some painting, putting everything together and seeing what it looks like. All right, so I did a bunch of work putting everything together, but before I do a big fancy reveal, there's a couple problems I gotta figure out, and I'm gonna take you along on the journey to see how I solve them. So the first one is that the vibration sensor seems to be picking up a bunch of noise from just the other digital signals in the circuit. On the one side of the vibration sensor, I've got 5 volts. On the other side, it goes to my microcontroller pin. What's happening is the microcontroller pin is seeing voltage when there shouldn't be any. So the way I'm gonna fix that is basically instead of having the other side of the sensor connected to 5 volts, I'm gonna connect it to ground and switch the pin to using a pull up resistor. So that means it'll be resting at 5 volts, and then whenever it vibrates, it'll go down to 0 volts instead of being the other way. So hopefully that should make it a little more immune to noise. I'll do that and I'll see if it works. That seems to have fixed the problem. So I have the vibration sensor very separated now from the LEDs. I assume it was the addressable LEDs, the data from this. It could have been the stepper motor line as well that was interfering, but now it's nice and separated. And we've got our vibration sensor here resting at 3.3 volts. I was saying 5 volts before, but the RP2040 is 3.3 volt logic. So 5 volts, 3.3 volts, whatever. But it's resting at 3.3 now, which means any voltage it picks up from anything else isn't gonna affect the signal. The second problem is that the stepper motor is making a lot of vibration noise right now. So it sounds like a constant rumbling sound, and that's to be expected, but I have some ideas how to reduce that. So right now it's just mounted directly to the housing, so any vibration is just going directly through everything. I'm gonna try putting some foam in there. Also, it's rubbing a little bit. The spinner is rubbing on the insides of the housing here. Probably just gonna change the model a little bit. So I'm gonna go do those things and we'll see if it works. So that helped a lot. The motor's pretty quiet now. It's like a subtle hum as opposed to like a constant vibration, so I'm happy with that. On to the third problem that needs solved, which is going to be how I do the soul orbs. And they're kind of the whole point of the sinner sacrifice, so I need to do this really well, basically. It's going to be a focal point of the project. And I did some thinking, and I think the best way to do it is going to be to have an inner shell like this. It's thin enough that the light will shine through for an LED. And then I'm gonna have this outer shell printed in black, which kind of has the like amorphous soul pattern on it. Obviously in game, the pattern kind of like morphs and actually moves around, but I don't think there's any realistic way I could achieve that. I modeled the outer shell to just be flexible enough to fit over the inner shell. So it just fits on there really nice. There's no glue or anything. And the last piece is gonna be this little cover that goes on the bottom. And for the LED, I'm gonna be using these 3-watt LED modules, the Adafruit cells. They're super bright. I'm gonna be able to program these to do a sort of fading effect to mimic how the orbs look in game. And there's just gonna be a daisy chain of like 18 to 20 of these in there. I think it's gonna give it a pretty like magical kind of glowing effect in there, so I'm really excited to see how it turns out. So I'm gonna go work on all this now. There's a little bit of sanding to do, some wiring, soldering, the usual stuff. It kind of feels like the economy is a little broken right now. People are just printing souls out here. Yeah, but you can see I've only sanded 2 of them. There's gonna be a lot of sanding to do here. And sanding is not my favorite thing to do. Alright, so I have all of the LEDs hooked up. There's a little bit of flickering. It gets worse throughout the chain. So the last LED here is blinking a lot, and the first one in the chain is completely fine. So it's gotta be the data pin. But to address it, I'm also gonna add this monstrosity that I've created. It's 520 microfarad of capacitance. I didn't have any 1000 farad, so this is the best I can do. All right, so there it is added to the circuit. It's not pretty, but it should help things run a little bit smoother. And I've also added a 470 ohm resistor in the data line right there, the green wire. That is a common solution people say should fix stuttering. We'll see if that works. Okay, so that has made things significantly worse, as you can see. I think the bulk capacitance was definitely a good change, but the resistor has exposed the need for a level shifter. The RP2040 uses 3.3 volt logic, and these LEDs are being powered at 5 volts, so they're expecting 5 volt logic. So I'm gonna need to add right in here, basically, a level shifter that will move it from 3.3 volts to 5 volt. I thought I could get away with not having a level shifter, but it seems like it's gonna be necessary here. So I'm gonna order that, and hopefully all this flickering will be gone. So I added the level shifter, and it's a lot better, but it's still flickering like it was in the beginning. So there's something going on here. I mean, this is crazy.
So I decided to hook up my oscilloscope and look at the 5 volts at the end of the chain, and this is what it looks like. It's not great. This is suboptimal for sure. That's about 4 volts, and it's super noisy. That's definitely the problem. The power is getting destroyed as it goes further and further across the chain. So my solution is basically going to be to hook up the power and ground on both sides so that both ends are connected to hopefully get enough power throughout the whole chain. I added this splitter in here, which just connects the power and ground on both sides, and yay, there's no more stuttering. You probably can't see it anyway on camera, but I solved it, finally. Now it's time to glue on our soul orbs like so, and then we'll have our chain of souls. So I just finished sanding and painting the soul orbs, and I gotta say these things came out absolutely beautiful. I love them. I'm really glad I spent the time to sand it. It was painful and I had no fingerprints anymore, but the smooth finish on the outer shell looks really good, I think. Damn, they look sick. I'm really happy with that. These things look so good, man. The glow is just like, I don't know, it just looks amazing. The morphing animation is a little bit subtle, so I might go in and change that a little bit, but I'm stoked. I'm not a big fan of how visible some of the cables are through the little gaps in the orbs. And there's also some space open at the top, like it's not full all the way. So I'm gonna have to do some thinking on how to fix those two things. My fiance had the idea to add a false back into the container so that I, number one, can route a bunch of wires behind it and try to hide them a little bit. And number two, the soul orbs will fill up the container more. So I printed it out and painted it gold to match the inside, and it just slides right in there. And now I can put the soul orbs in and hopefully hide some of the wires, and it'll fill up a little bit nicer. So I just spent 4 hours trying to fix a software issue where the soul orbs were flickering for no reason. And of course it ended up only being a single line of code that I had to change. Shiloh's in my seat again. But I got them working. Looks a lot better now. You can't see the wires as much and it fills up a lot more. You can see the divider here. Got all the wiring hidden behind there, so that's nice. Very clean. And it also seems like I'm not gonna have any significant heat problems. I can definitely feel the warmth, but it's not too hot. All right, so we've only got 2 things left to do, okay? I mean, I love this project, but holy I'm so excited to be done. And I know you wanna see the final product at this point, so I'm gonna get through these last 2 really quick. So the next thing to do is to get the graphics onto the spinner. And if you look in game, you'll see a ton of different icons that they have on there, little pictures of candles, a horseshoe, a moon, an eyeball. So the way I want to get those pictures on there, I think the best way to do it is to use my multicolor printer here to just make a very thin model. And I'm lucky enough that my fiance was able to trace me all of the icons into vector format. And then when I printed it, it'll only be a couple layers tall, and I'll be able to just wrap it all the way around the spinner. So I printed them out and then I glued them on the spinner, and luckily it just all lined up perfectly and I got the dimensions right on the first try. The wheel has like the perfect amount of grip on the spinner, and I think it looks great. All right, so we're on to the last thing, and that's gonna be to add a volume knob. Throughout this whole project, I've spent so many hours just listening to the idle music that I realized it would probably be nice to have a volume knob on this thing. So I'm gonna add a potentiometer onto the bottom plate. I'm just gonna drill a hole straight through, and then this will connect to the microcontroller and give me a variable resistance that I can use to then control the volume level. And with that on there, I can finally preserve my own sanity. I think I can finally say that this project is finished. It's time to show you the final product.
If you've made it this far into the video, I really appreciate you watching. This project took many months and a lot of time and energy to make, so I hope you enjoyed it. I would really appreciate it if you liked the video and subscribe to my channel for more projects just like this. And if you want the design files for this project or any of my other projects, as well as some instructions on how you can do it yourself, then please check out my Patreon where that stuff is all available.